Hey, it's the last video, yay. Alright, so, number one, it's not too hard. Hopefully you'll have the notes on how to do chi-squares. If you don't, that's okay. I'll tell you the equations anyway. So, the first problem is a goodness of fit. So if you have the equations, that's what you're using. If not, the equation for chi-squared is the sum of, in parentheses, the observed minus the expected squared over the expected. So that equation looks like this. Okay. So, so you're going to look at the information they give you, and you see that it's 19, 181, and 20. Also, the way I did this, I'm not sure if this is right, but I'm pretty sure it's right. They said that the probability is 6.5% for the bride and groom to have the same initial. So what I did is I just multiplied 200 by 0.065 to find the expected value for the same initial, and then I just subtracted that from the total to find different initial expected value. So once you find those two values, those expected values, then you're going to do 19 minus the expected value for the same initial over this expected value for the same initial. So the expected value would be 0.065 times 200. So that's your expected value. And then you add that to 181 minus the expected value for different initials over the expected value for different initials, and that will equal your eta squared value. And to find the critical one, you click on the little thingy and you set degrees of freedom to 1, because you're only using, it's just your categories minus 1, so you have 2 categories, minus 1 is 1. So that's the degrees of freedom. You're going to use just the one line, and you're going to make the proportion in the tail, which in this case is the orange part, to 0.05, and that orange number on the bottom is your critical value. So you'll write that in, and then if your eta squared is larger than your eta squared critical point, then you reject the null hypothesis, and there is a difference. So that's not the answer, just remember that's what you do if that's what it is. Okay, so number 2 is a little bit longer, a little bit more confusing because I wasn't sure which set of data we were supposed to use. I just assumed that we're using the smaller set of data. You're gonna have to calculate eta squared or chi-squared excuse me chi-squared anyway for both of them, but I wrote in the smaller data for chi-squared. So again, this is not the goodness of fit. This is an independence test of independence or something. It's the same equation. It's just you have to find a couple more things. They don't give you the probability of things anymore. Instead, they give you all these numbers, and you're like, oh, cool, that's great. So basically, on the first little box, you want to find the lower right hand blank one. So that's going to be your total, like your capital N, and that's just going to be either 150 added up or 960 added up. It doesn't really matter. It's just like that's the total. So because it's really easy, it's 150. So 150 is your total. So then to calculate the expected differences, you do the row times the column divided by the total. So to find your city favor expected amount, you would multiply 50 by 90 and then divide that by 150, which is your total, and that'll give you the expected value if it was a random assignment. So that's what you need to calculate. You need to calculate that for all 4 of those. So for city favor, city oppose, suburbs favor, and suburb oppose, and then you're going to do what we just did in the other problem. So you're going to do 35 minus the expected value over the expected value plus, you know, all of the other ones. So yeah, do remember that it's row and column, so it's just like looking in the table, so you have to make sure that you have the right row and the right column going to the same number. So for suburbs favor, it would be 100 times 90 over 140, so just make sure that you're doing that right. I did that wrong a couple times and messed up my answers. So once you have eta squared, or not eta, sorry, it looks like, I don't know why I call it that, it's chi. Once you have chi squared, they don't give you the table this time, so this time you just go in the book. It's the very last one. If you're using Applia, it's in Appendix B, and it's the last table. Just go down to there, and we're using 0.05. So go to 0.05 for a 1 degrees of freedom, because degrees of freedom for independent tests is your rows minus 1 times your columns minus 1. So you have 2 rows and 2 columns, both minus 1 times each other is 1. So that'll be your chi critical. And if your chi squared is bigger than your critical point, it's significant and you reject the null hypothesis. And so then it's going to ask you another one that's like, what does a larger one do? So calculate the larger one the same way we just calculated the other one. So to find your expected value for city favor, you do 100 times 180 divided by 300, as opposed to whatever numbers they were last time. And then again, you're going to have to do 70 minus your expected value over your expected value, you know, whatever. Hopefully, when I held up the equation, you noticed that it's observed minus expected squared over E. I think I said that. I'm not sure. I know I didn't say that when we were talking about this problem, but just remember to square it. If you haven't done that, sorry. Just make sure you square it, and then divide by the expected value, of course. And then just depending on what your eta is, or chi, then you can answer the next question. Okay, and then they want you to calculate the phi coefficient. So to do that, it's a pretty simple equation. Phi equals the square root of x squared over capital N. Or x. Chi. So whatever your chi value is, square it, divided by n, and then take the square root of that number, and that is your phi coefficient. And remember that capital N is just going to be your total, so it'll be 300. Yep, and then you have to do that for both of them, and then you can answer that next question. So then on number 3, it has a beautiful, beautiful table that we have to fill out. So, easiest thing to do, well, I did, is I just wrote down my own table. It's the same thing, it's just in a different format. So, you see how there's a 16, 34, 7, 43, 6, 44, and then they give you the totals. So basically, same thing. To find your F expected for smashed into, yes, you would do 50 times 29 divided by 150. What's nice about this one is that it's 50 for all of the rows, so you really only have to do this once because they're all the same, or twice. So you do 50 times 29 divided by 150 and 50 times 121 divided by 150, and then you have your answers for your 3 and your 3 expected. So yeah, and if that didn't make sense, go ahead and just do them all. If it did make sense, good for you. You are saving yourself a little bit of work. So just write those in. Okay, and then it says to calculate the chi-squared term, which I was like, what the heck is that? It's just your observed minus your expected squared over expected. Because the formula for chi-squared is the sum of all of those, so their chi-squared term is just one of those that you add to all the rest of them. So calculate those for all of them, and then calculate the totals, and you add the two totals together, and you get your chi-squared value, which is great. And then before, they wanted you to calculate the chi-squared critical. It's the same thing.